Hello everyone, and welcome to Part 3 OOP Project Solutions lecture. In this lecture, we're going to be coding through an example solution to the Card War Game project. Let's hop to the editor and get started. Okay, here we are at the file, so let's scroll down and get started with the object-oriented programming of the deck class. So the first thing we always need in a class is the init special method to initialize this, and it will always take in self. And just to make things obvious, I'll add a print statement in here. You usually don't have print statements like this, but we'll just add it in anyways, and we'll say creating new ordered deck. And then what I'm going to do is say self dot all cards is equal to, and what I could do is have the logic be inside the initialization or have the logic be outside the initialization. So what I mean by that is I'm going to have a global variable here called myCards and set that equal to a list comprehension that is tuple for the suit and the rank of the cards, and say for S and suits or suites for R in ranks. So that's one way to do this. You could have also done this with a nested for loop. So just to walk through that example, you could have said something like for R in ranks, for S in suites, and then have some, you could say myCards.append SR, a tuple there, with myCards being equal to some blank list. So this is the exact same thing as this. So keep that in mind. If you need to pause the screen and kind of break down this list comprehension and compare it to this nested for loop, that's all that's happening here. But I could then pass in my cards over here during the initialization step. But instead of doing that, I'm just going to grab this list comprehension, delete this, and then put that in here. Okay, so that actually creates the deck, and it all happens inside the class. Again, you don't have to do it this way. There's many ways to actually do this, but we'll just create the deck here. So that's a new ordered deck. If I want to shuffle the deck, I'll pass in self. And then let's add in a print statement just to make things really obvious, since this is a project to learn with. We will say shuffling deck, and I will call the shuffle function on that list, which is self.allCards. And then I also want to be able to split the cards in half, so I will create a new method, split in half. That takes in self. And then what this is going to do is it's going to say return self.allCards. And I know there's 52 cards in a deck, so that I need to go from the beginning all the way to index 26 up to but not including it, and then self.allCards from 26 onwards. So that will return a tuple of the split cards. Up next is the hand class. So this is the hand class, and each player is going to have a hand, and they can add or remove cards from that hand. So what's going to happen here is I will initialize this with self and then cards, and then I will say self.cards is equal to cards. And then let's also have a method here, a special method for printing out the hand. So I'll pass in self, and let's return using print formatting contains blank cards, and we'll say dot format, and let's return the length of self.cards. That way I know how many cards is in the player's hand. So that's what's going to happen if I ever print a hand. It's just going to report back how many cards that player has in their hand. Then finally, I want the two methods that are add or remove. So I will create an add method, which takes in self and then the added cards. So that's going to be a list. And I'm going to say self.cards dot, and I want to not append, but extend my list with the added cards. So in the middle of the table, they're the cards that the computer played, the cards that you played. That will be a list, and then we will extend that list. Maybe you decided to do it a different way. That's totally fine too. And then we'll have a method called remove card. That will just be self, and this will pop off the top card here, or the very last card, I should say. Cards.pop, and there we go. Now we have the class player. So let's play around with that. First off, I want to initialize the player. So we'll say underscore underscore init self, and a player should have a name, and they will also have a hand. And then I will say self.name is equal to name, and I will also say self.hand is equal to hand. And let's create some more methods here. I'll create a play card method, and the play card method is going to have a variable called drawn card, which is just self.hand.remove card. So remember, remove card from that hand object, so the player is going to get a hand object when we actually create it. I can call remove card and add card from that hand object, which in my case is just self.hand. So this is sometimes a little bit confusing because you kind of see these multiple calls here, but it's just self.hand.remove card. And then let's add a print statement so we really know what's going on here. I'll say brackets has placed, brackets, and then let's say dot format, and I will say self.name, so that's the player name, has placed, and then we'll put in the drawn card. So whenever I play a card, it will say player has placed, and then whatever card I drew. And then we can also print a new line here. So that way our console, when we're printing a bunch of stuff, doesn't actually get stuffed with a bunch of commands. We can read it better. And then finally, I want to return the card I drew, which is the drawn card. The next method I want is some method to remove the war card. So we'll say remove underscore war cards, self, and then what's going to happen here is I'll have a local variable called war cards, set it equal to an empty list, and I will say for x in range 3. So if both the computer player and you pass 2 cards and they're the same rank, then we have war. So I'm going to need something to actually remove the 3 top war cards. So I'll say for x in range 3, war cards dot append self dot hand dot cards dot pop. So what's actually happening here? Well, if I match with the computer, I need to grab those war cards, and I will grab them as a list and return them as a list. Then I'll say for x in range 3, which basically means for these 3 cards, take the war cards and append self.hand.cards.pop. And we could have also done that with remove. It's really up to you. There's so many ways to do this that you shouldn't feel obligated to do it exactly like I did it. So here we see hand.cards.pop. What could I have also done is just remove card, which is self.cards.pop. So again, .cards.pop, that should be the exact same thing as me saying remove card. So I could have done with this, remove card. That's the exact same thing. Choose whatever makes most sense to you. Usually you'd probably want to actually take advantage of the method, but we'll leave it the other way for now in case this may be a little more clear for the user, but it's really up to you. And then I also want to have a method here called still has cards, and all this does, and we can add in some documentation here, or a doc string. This will return true if player still has cards left. Because remember, when a player runs out of cards, then the game's over. So what I'm going to do is just return the length of self.hand.cards, whoops, that should be a h, is not equal to 0. So that will just return true if the player still has cards left. Okay, so we just created a whole bunch of functions. Let's quickly review all of them. So starting from the very top of the deck. Remember, I have these 2 helper lists. What I do here is I create this object, self.allCards, and that's just this giant list of all the cards in the deck. Then I can shuffle all the cards in the deck, and then I can split that deck in half. And note, when I split the deck in half, I actually return a tuple, which means I can use tuple unpacking to grab the first half of the deck and then the second half of the shuffle deck. Then I have the hand class, and what this does is it just reports back how many cards I have here in this hand. Then I can add cards to the hand, which is extension, and then remove card, which pops a card off. Then I have the player class. The player has a name and one of those hand objects. They can play a card, which means they just remove a card, and it tells you what card they place down, and then it returns that drawn card. We also have remove war cards, which means if I have war present, then I will call range 3 and remove those cards. Again, I can use .cards.pop, or I can just call .remove card. It's up to you, whatever's more clear to you. Then I have DF still has cards, which just returns true if the player still has cards. So now let's actually say welcome to war and begin. I want to use all three classes to do this, so let's kind of mark down what we have to do first. To do this, what I have to do is create a new deck and split it in half. So let's do that. That should be T there, create. So I'll create a new deck object, set it equal to D. And let's zoom in here a little more so we can see what's going on since we're towards the bottom. Let's make some space for us. So I create a deck object, and I'm going to call the shuffle method on that deck, and that's in place. And then I'm going to use tuple unpacking to grab the two halves of the deck, half one, half two, and that's just going to be D.split in half. And then I want to create both players. I'll create the computer player, which is going to be a player object called computer, and then it's going to accept a hand object made out of the first half of the cards. And then for the human player, we want them to provide their name. So we'll say input, what is your name? ? And then we'll call this object user, and that will be a player object with that human provided name, and hand is just going to be half 2. And then basically war essentially plays itself. So it's such a simple game that there's no strategy to it. You just keep flipping the cards, check who won, and then take the cards. And if they match, you play war and then just check who won the war. In that case, let's actually make this kind of automatically play. So I will say total rounds, let's not make this a comment, is equal to 0. And then I will also check the war count and see if that's equal to 0. And basically what I'm going to be doing is automatically playing this game for both the human player and the computer, since they essentially don't have to make any decisions. That's how simple a game war is. We will say while user still has cards and the computer still has cards, we will add 1 to the total rounds. So I will say total rounds plus equal 1. And I will print out time for a new round. And then I will also print out here are the current standings. And then what I'm going to end up doing is saying print user.name plus has the count. And then I actually want to grab how many player or cards are left. In that case, that's just the actual length. So I will say has the count plus, and we'll cast it to a string. There's many ways you could do this. You could also have built in your own str special method inside of this. And we can say user.hand.cards. And we're going to do the exact same thing for the computer. So let's do that as well. But instead of username, it will be comp for computer. And instead of user.hand.cards, this will also be comp. All right, very simple. And then we're going to say, just tell them both, play a card, and we will print a new line. So that's just the printing setup of the game. We're going to represent the cards that are on the table that's in between the player deck and the computer deck with a list. We'll say table cards is equal to an empty list. And then when we actually play cards, we'll take the computer card, the C card, and say comp play card method. Remember that returns the card. And then we'll also have a player card, P card, and say user play card. And then I want to add that to the actual table cards list, which means I'll do something like table cards dot append the C card. We just need to use append since it will be a single card. And I also want to say table cards dot append the player card. Then after that, I want to check if there's a war. So if C card of 1 is equal to P card of 1, I'm going to add 1 to the war count. So I say colon, and war count says plus equal 1. And the reason I have to use this indexing for 1 is because remember, if we scroll all the way back up to how we define cards, cards are just tuples themselves. So cards are just tuples that have this suit value and then the ranking. And the ranking is what I want to actually compare. So that's at index 1, which is why, scrolling all the way back down, when I actually have the cards to compare to each other, I want to grab their rankings and compare it to each other, which is why we had that indexing 1. Okay, so that means we have war. So we'll say print war. And then I will grab the table cards, and I'm going to extend the table cards now by user remove war cards. So that just takes the top 3 cards they have available. And then I'm going to do the exact same thing for the computer. So extend comp dot remove war cards. So I've grabbed the war cards now, and then I want to check who has the higher rank. So if ranks, let's say if ranks at the index of C card 1 is greater than, or let's say less than, the ranks at the index position of P card 1, we will say user dot hand add table cards. And then we'll say else we'll add it to the computer's hand. And this doesn't take into account a double war situation. In a double war situation, we'll just say default the computer wins. Again, you could keep adding more logic if you wanted to. All right, so let's actually break this down and kind of explain what's going on here before we continue. This first if statement at the very top is checking the computer card's ranking versus the player card ranking. And if that occurs, then I have a war. So I want to say +1 to the actual war count. And I print out war on the console. And then the cards on the table, remember so far it's just 2 cards, the initial computer card and the initial player card. I'm going to extend it with 3 cards from each deck. 3 cards from the user deck, and then 3 cards from the computer deck. And then I will say this. Remember ranks is that very top list where I have all the ranks right here. So the ranks are conveniently in order, which means I can compare the index position, and the greater index position counts for the higher rank. So then scrolling all the way back down here, what I'm doing with this .index call off of this ranks list is asking where is the index for this particular ranking, and where's the index for this particular ranking. So where's the index of the computer card in the ranks list, where's the index of the player card in the ranks list. And if this, the computer card, is less than the player card, then the user gets all the table cards. Else, the computer is going to get all the table cards. So the player is only going to get it when the computer card ranking is less than theirs on that war. Otherwise, the computer gets all the cards. So even in the case of a tie, we'll just let the computer have all those cards. We could add more logic to check for a double war situation, but we won't worry about that for now, just to keep things very simple. And then I need an else statement to go along with this initial if statement. So far, I've checked for war. That's kind of the hard part. The easier part is if there is no war, then all I have to do is directly compare the actual cards. And that's essentially the code I have right here. So I can just copy this and paste it. And that's all I have to do, because in this case, I don't have war, so I just need to compare C card 1 and player card 1, and then add the appropriate cards. And then what I'm going to do after all of this has been done, meaning this while loop has finished executing, so the user still has cards and the computer still has cards. Eventually, one of them is going to run out of cards. I want to print out how many rounds it was. So I will say print game over, number of rounds, colon, and then we can just say comma, or I can say plus, the string representation of total rounds. And then I can also say print a war happened. I'll say plus the string of the war count. And we'll say plus times. And that way we can report back how many rounds we had and how many times we had war. So let's save this. I have this all under notes.py. Okay, so it looks like the majority of our code is done, but before we actually run this, it's always a good idea to actually kind of do a quick pass over and see if we're missing anything or not thinking of anything correctly. So if I go all the way to the top, we can kind of check on this. I'm saying for random import shuffle, that looks okay. These two look okay. Class deck, let's check all the methods in each of the classes. Def init, self.allCards, and it looks like I'm accidentally missing a in statement here. So for S in suite or suit, for R in ranks, shuffle, that looks okay. Split in half, that one's looking okay. Class hand, init, the string, add, remove cards, that's all looking okay. Player, init, that looks okay. Play card, that also looks okay. Remove war cards. So an issue that may arise here with this remove war cards is that if I end the game on a war, I may not actually have 3 cards left. So what I mean by that is if the computer has most of the cards and you have 2 left, and you happen to draw war, you may get an out of index error when calling for range 3. So let's actually add a little bit more code here to check for the war cards. So I will say if the length of self.hand.cards is less than 3, I will return all the cards, which is just going to be self.hand.cards. So I will just return all the cards as a list. I won't even bother popping anything off of them. And then I'll have the actual for loop become an else statement. So then we can do this. Else, for this, return that. So now let's save this, continue on. Still has cards, that check makes sense to me. Gameplay, we just went through all of that, so it should be okay. We check if both players still have cards, we keep running this loop. We take the computer card, the user card, add them to the table cards. We check to see if there's war. Otherwise, we just check those individual cards, and then we play the game. Okay, let's run this and see if it all works. I'm going to open the terminal here, and then I have this under notes.py, so I will just call Python notes.py, hit enter. Looks like it's starting off okay. What's your name? We'll say Jose. Hit enter, and it looks like the game actually works. So we say game over, number of rounds, 178 rounds, war happened 16 times. And right now we're actually not reporting who won, which isn't so great. So let's actually report back who won. And the way to do that is just report back their length. So we'll print out computer has, and then let's check how we can grab how many computer cards there are left. So that's the comp still has cards. We can actually just report this back itself. So we'll say computer has, well, instead of saying computer has, we'll say the computer, does the computer still have cards, question mark, and then we'll print back comp still has cards. We'll just turn this into a string. This will either be true or false. So that will be a string, and then we can do the exact same thing for the player. And this will report back who won. Does the human player still have cards? This will end up being user. Okay, so let's save that, run this again. Say Jose is the name, and then it looks like the computer still has cards, true, so the computer won that time. 130 rounds, war happened 16 times. Let's run this one more time to make sure everything's working. Shuffling the deck, we'll say new, and then computer won again. Let's try to make sure the computer doesn't always win. And great, so the human player still has cards, true. And interesting enough, war happened 0 times, and it was won in just 36 rounds. Okay, great. If you have any questions, feel free to post to the Q&A forums. This is a very challenging project, so if you weren't able to get it on your own, especially given that we just learned about object-oriented programming, don't worry about it too much. We won't ever have to do something this complicated in Django. A lot of that work's already done for us. We just need to know the basics of adding methods to objects. We won't be doing anything this complicated when we talk about Django and building our own web applications. Again, any questions, make sure to check out the solutions.py file and check out the Q&A forums. Thanks, and I'll see you at the next lecture.